students, welcome to the IMS Gate Academy. How are you all? And before that, please let me know whether my audio video both are clear or not. Anyone, please do let me know, audio and video. Is everything perfect? Alright, so as you already know that we had started this GATE score booster session and we have seen a tremendous response from the student sides, and in that I had taken the electrical machine, if you are knowing, and even if you are not knowing, I had already taken the GATE score booster session on the electrical machine. So those who have not yet watched, please go and watch those particular session once this session is going to be completed. Alright, so all in all I had taken around 32 question of the maybe 31 or 32 like that. So overall I had taken that question, and in the electrical machine who belongs to IN and EE, definitely please watch those sessions. Definitely you are going to have the wonderful experience, and you will going to learn such a thing that you have never ever experienced. Alright, so in this session we will going to cover the subject measurement, and again it is common for both EE and IN. I know that the EE student must be wondering that, sir, we are having the less weightage in the measurement, then why to study? Then my dear friend, you are very wrong, because if you compare this with the cricket, in the cricket every run is important. In the same manner, every marks is important in the GATE exam. Okay, each marks decide your rank, whether the rank will be 1 or 2. So please do not think in that manner this subject is a less weightage, so we should skip those things or those subject, and those who are the higher weightage we will going to cover only those things. No, it is not that. Alright, so in this session we will going to cover the measurement part 1, and in the part 1 I had taken certain chapter, and the remaining chapter I will be going to cover in the part 2, which is on tomorrow. Alright, the timing will be the same. So in the part 1, what we will going to discuss, we will going to proceed from the chapter 1 to till chapter 4, and we will going to see some good number of question. Maybe those question are par than the GATE level, but definitely from those question you will going to have at least some portion in the GATE exam. Okay, so please do not get worried about the lengthy solution and those things. Alright, and one request, please do ready with your pen and paper or maybe the rough copy, because once I will going to show the question, after that I will going to give you certain amount of time to solve those particular question. Okay, so in those particular timing you will have to solve. It hardly matters to us whether you are getting the correct answer or not. We are here to learn. We are here to rectify our mistake if you are doing anything. Okay, so first do solve it, and after that, once the time is going to be over, I will going to start the solution. Alright, so again one more request, please do share the session link with your friend, and also to please hit the like button so that I come to know that how many of you are present over here, and please inform your colleague that we had already we have already started the session, and we will going to cover a lot of things in this particular session. So please do inform your colleague and friend. Alright, so let us start with the some important points, which is the chapter 1, basics of measurement and error analysis. So this is a chapter 1. Now under this chapter, what important topics we are having? Like these important topics are with respect to your GATE question. Like if you see the past 10 to 15 years of question, na, the GATE authorities are asking the question from this particular topic. Alright, so like see, in this chapter we are having some other topic, but those are not at all much important when you compare those topic with this one. Got the point? So in this, the first important topic is the limiting error or tolerance. The second topic is standard deviation or uncertainty, and the last one is the equivalent error. So all these three topics we will going to cover through the practice, like whatever question I have taken from here, we will going to practice this particular topic through the question, and we will try to learn the concept. Okay, please do not by heart the steps. Try to learn the concept, and from there once you're going to understand the concept from the very first question, those concepts you will going to utilize in the second question. Okay, so let us see the very first question that we are having. Okay, so this question is basically a combination of your control system and the measurement. Okay, so please do not think, sir, this session is measurement, then why you are giving the question from the control system? Like if you see the GATE question, they were giving the question from the combination of more than 2 subjects, like analog, control, network, so on. So like they combine the 3 subjects and they will give you one question. So I don't want to make the session to be more complicated, so that I have come up with only 2 subjects, like the combination of a question from the 2 subjects. All right. So this is the very first question. So let me give you the time. I will give the 3-minute time for this. Okay, yeah, 3 minutes. Let me check. Yeah, okay, 3 minutes for this. After that, I will going to start the solution. Okay, please. Once you solve this, once you are able to solve the particular question, please do answer in the chat box. All right. So your time starts now. The question is very simple. Let me give you a hint. Find the transfer function and then apply the concept of tolerance. Any answer? Okay, sorry, not the tolerance. The concept of uncertainty means standard deviation. Uncertainty means standard deviation. Seconds remaining. Do it fast. Last 20 seconds. Last 10 seconds. Okay. The question is, two elements R1 and R2 are connected as shown in the figure. Calculate the uncertainty in the error signal E for an input of unit step. Round off to 2 decimal places, where R1 equal to 100 plus minus 1% units, R2 equal to 200 plus minus 1% unit. So this is our block diagram, and we need to find the standard deviation in the error because of these 3 elements. Okay. Now the uncertainty, as I told you, it is a standard deviation, and we know the error can be defined in two manners. The first one is the limiting error or tolerance, and the second one is standard deviation or uncertainty. The formula for both the approach are different. Okay, for the tolerance the formula is different, and for the uncertainty or standard deviation the formula is different. So look at here, R1, this is given as 100 plus minus 1% unit. So your variable is represented in this manner, which is in percentage. So this such kind of notation or representation basically is known as relative. Okay. So this is your true value. The first parenthesis is the first value is the true value plus minus sigma R1 T. What is sigma? Representation of standard deviation. Okay, so I hope you are getting the concept, not the sigma, percentage basically. All right. Now this can be also represented in absolute manner. How? See, or R1 equal to 100 plus minus 1% of 100 is 1. So the same error is now represented in absolute manner. This color is visible, please do let me know. Absolute manner. Okay, but here R1 true will be same, only change in the representation of the error. Okay, so earlier it was in percentage, now it is in absolute. In similarly your R2, this is not the resistance, please see carefully, this is not the resistance, it is any variable which is represented as R1. Okay, next R2 is 200 plus minus 1%, 200 plus minus 1%. Okay, so this can also be represented as 200 plus minus 2, means 1% of 200 is 2. So this is in relative and this one is in absolute. So this is nothing but R2 true plus minus sigma R2. Okay, extremely sorry, this is not the true one, this is R1. Okay. Now we need to find the error due to the reference input. Now please find the transfer function E by R, and we know how we can find, by using the Mason's gain formula. So using Mason's gain formula, E by R. Okay, first find the loop. How many loops we are having? Only one loop. So this is one loop, and now see the feedback. Feedback is positive. So it is R1 into 1 upon R2. Done. What is forward path from R to E? Means gain, it is 1. And what is del 1 value? Del 1 value is the loop which is not touching that path. So see here, from R to E, we are having this loop which is touching. Therefore, del 1 value is again 1. So overall, we can write this as R2 upon R2 minus R1. Okay, so error from here, error is input into R2 upon R2 minus R1. Okay, all right. So we have got one expression. Now let me give you the formula, like how we can find. Suppose you are having a function x, okay, and this function x is a combination of independent variable. Let me take a variable like this, small x1, small x2 upon x3. It can be anything. It can be anything. So I have taken a general case where x1 into x2 upon x3 we are having any independent variable which gives you the equivalent function as x. Now suppose your x1 is having the true value as x1 true plus minus sigma x1. Like here it is given, like this. Similarly, x2 is having x2t plus minus sigma x2, x3 is x3t plus minus sigma x3. Then the standard deviation in capital X, let me take sigma x, okay, in capital X is equal to plus minus root over, please take the formula very carefully, plus minus partial derivative of x with respect to first variable, sorry, okay, whatever, what do you mean a partial derivative means other variable is taken as a constant into, sorry, let me write it clearly, x1 into error in sigma, sorry, error in x1 like this, and take the whole square, plus partial derivative of x with the next variable x2 into sigma x2, take the whole square, plus partial derivative of x with respect to the next independent variable into error in that variable. So in this manner you will going to get the standard deviation in the equivalent variable. So let me inbox this. Done. So this formula is very, very important. Now we will going to use the same concept in this expression E. So how many variable we are having here? R, R1 and R2. So 3 variable. So let the error in E be sigma E. Let me change the color, just a second. So let the error in E be sigma E, which is equal to plus minus root over partial derivative of E with respect to first variable, which is input R, into sigma R whole square, plus partial derivative of E with respect to the next variable, which is R1, into sigma R1 whole square, plus partial derivative of E with respect to next variable, which is R2, into sigma R2 and whole square. Done. Okay, so let me find the first variable, the first derivative, which is sigma, partial derivative of E with respect to del R. Anyway, even if you are not want to find this derivative, it will automatically goes to 0, the first term. Why? Because the error or the standard deviation in the input is not given. See, we are having the error only in R1 and R2, and in the input R, which is unit step, means the value of R is 1, and what is the error in the input? It is not given, so we will going to take it as a 0. Got the point? So in that case, I can directly make this value to be 0. Got the concept? Next, let me find del E by del R1. So what is E? E is R into R2 upon R2 minus R1, where R2 and R both are constant. So let us differentiate it R. Okay, so this is U by V form, na? So we can differentiate like this, R2 minus R, U by V means at the denominator we are having the denominator ka square. Okay, so second term and second term differentiate first term, which is R2, again it will be 0, minus first term, which is R2, differentiate second term with respect to R1. So we'll get 0 minus 1. So क्या मिल रहा है यहाँ पे देखिए, R2. So what we are getting? We are getting 2R2 minus R1. So we are having the values of 2R2 minus R1 upon R2 minus R1 का whole square. Okay, please check. This is R1 and this is R2. So R1, R2 goes to numerator. Done. Okay, correct. So this is R2. Here R2 we are having. Okay, let me check the, and also please you also check whether the derivative quantity is correct or not. Okay, yeah, this is wrong because R2 minus R1 is 0, na? R2 minus R1 into 0. So this part will be 0. Okay, so we are left with R2 only. Okay, R into R2 upon R2 minus R1. In the same manner, let us calculate. Just a second. Let us calculate partial derivative E with respect to R2, na? Okay. So differentiate it. Partial derivative of E is R into R2 upon R2 minus R1. Okay, where R is the input which is constant. So let me take it out. So the derivative of it with respect to R2. Let us see what we are getting. Here R2 minus R1 into 1 minus left the numerator R2 into 1 we are going to get here R2 minus R1 ka whole square. Okay, so what we are getting? We are getting R. We are getting R times R2 minus R1 ka whole square, and here R2 minus R1 minus R2, what we are getting? Minus R1. Alright. Now if you look at the expression very carefully, what is this R2, what is this R1, what is R? Those are the true value. R का true value क्या था? Unit step, amplitude is 1. So R value is or R true is 1. What is R1? True value 100. R2 true value 200. So substitute all the values here. Okay. Meanwhile, let me change the color. Just a second. Please do find the values. Let me change the color here. Okay. So this value is 1 into, okay, R2 is 200. R2 minus R1, 200 minus 100 is 100 ka square. Done. Here what we are getting? Minus 100 upon 100 ka square. Okay. So we have got the values of this and this. Let us substitute. Okay, just a second. So this implies sigma E is equal to root over 0 ka square, because sigma R is 0, plus this value is 200 by 100, 200 by 100 square into what is sigma R1. Okay, what is sigma R1? Sigma R1, I guess it was 1. Okay, this value 1. And whole square because of this formula, plus 100 by 100 ka square into sigma R2 was 2 and whole square. On solving this, okay, we forgot this plus minus sign. So plus minus, on solving this, we are going to get the answer as minus 100. No, it was minus 100. Let me check. Yeah, it was minus. Anyway, after squaring, it become plus. So after this, we are going to get the answer as plus minus 0.03 units, like this, which is the correct answer for this question. So what we need to pick the option, we need to pick the option as option C, which is the correct option. Alright, any doubt in this question? Please do comment in the chat box. Any doubt? So, in this manner, whenever you are having question related to the uncertainty or standard deviation, in this manner or by the help of this formula, we will going to solve. I know it is lengthy, but in the GATE exam, you may not going to get such lengthy problem. Okay, only some portion of this. So, I hope you have got all the concept. So, let me take you few minutes. This is our online live program for GATE 25 and for GATE 26, where we are providing the 800 plus hours of the live class with interactive live session. Next, theory book, exercise books and 30 plus year GATE question bank with video solution. So, we are providing, see, we are providing the theory book, exercise book of every subject. So, this theory book and exercise book are so framed, or it is so made that once the student is going to start the particular subject, will feel comfortable in that. So, we are having the level 1, level 2, level 3 category in the exercise book, so that as per the comfortability or as per the confidence, we are going to or the student are going to build up their concept. Alright, and we are providing 30 plus year of GATE question along with the video solution, which is very important. 12 personalized one-to-one mentorship session. So, we are providing the student to interact with the faculty in one-to-one basis. So, all in all, they are getting 12 personalized mentorship. And the next one is 130 plus online test with video solution of mock test and many more. Alright. So, if you want to have the counsel, then you can book a free counseling by calling this particular number. So, we are having the two numbers over here. So, you can call in any of the numbers. Definitely our team is going to help you, or else you can find the link in the description box. Alright. So, Abhishek Shahukare. Okay, alright. So, Abhishek, please do hit the like button and please share the session with a friend, and please be here, because I am coming up with a lot of good conceptual question over here. So, I want you to solve each and every problem and at least give a try. Alright. Next is, this is our Telegram channel. So, whatever thing that we are going to discuss or whatever thing we are conducting over the YouTube series, you will going to find the PDF of the session in the Telegram group itself. So, what are the features or what are the things that we are giving at free of cost? Scheduled free YouTube lectures, lectures PDF, important updates related to the seminar and webinar, PSUs and other government job notification, expert session on the important topics, daily quiz and many more. And the link is already given in the description box, or else you can visit this ID. So, from any one of this you can join our Telegram group. Okay, and as I told you, the PDF of this session you will going to get in the Telegram group itself. Alright, so let us come to the next question. Do we have any doubt in the first question? Any doubt in the first question? No? Yeah, let us start with the next problem. Resistance R1 and R2 have nominal values of 10 ohm and 20 ohm and tolerance of plus minus 10% each. The possible values of resistance in ohm for parallel combination of R1 and R2 is R. So, this is MSQ type of question where more than one option can be correct. Alright. So, let me give you 1 minute for this, not more than that, 1 minute for this. Your time starts now. Do it fast. 25 seconds remaining. Abhishek, you are from EE or IIN, and for which year you are opting to give the GATE exam? All right. So see, let me take the parallel combination as R, which is R1 parallel to R2. So I can write this as R1 into R2 upon R1 plus R2. This is how we can find the parallel combination of a resistance. All right. Now in the given, let me take this as 1. Now R1 is given as 10 ohm plus minus, error is okay. See, this is tolerance, so means here error is specified as limiting error, not as a standard deviation. So the error in each resistance is plus minus 10%. So 10% of 10 is what? 1 ohm. So this we have represented in absolute manner. So whenever the error are specified in percentage, we can directly find the absolute or its equivalent error in terms of unit. Okay. So means 10% of this. So this is what? This is your real value R1, sorry, the true value plus minus error in R1. For standard deviation, we will be using sigma, and for tolerance, we will be using del R1. All right. So R2 is 20 ohm plus minus 10%. So it is 2 ohm. So this is absolute. Again the same thing, R2 true plus minus del R2. One more thing, we can solve this, like we'll be solving this question by using two methods. Okay, so this is method 1. Just a second. Okay, so this is method 1. All right. So see how Abhishek, option C, Abhishek is saying option C. Abhishek, please check the calculation. Maybe you have did some calculation mistake. Please check it. Abhishek, yes, double E. Okay, and targeting for gate 25. Okay, so you are having the great chance to crack the gate with a good number of marks or with a good rank. All right. So definitely please do attend the session, and I am 100% sure that you will going to learn a lot of things which you have not yet studied in the your BE or BTech. Okay, so in which year you are currently? Third year, I guess. Okay, means the semester. I think you are in a 6th sem maybe. All right. If you are not a dropper, then definitely you'll be from the 6th sem. Okay. Anyway, please do reply in the chat box, Abhishek. All right. So you have given option C, which is as of now not correct. Okay. Please do check, and I am 100% sure that you will going to get the correct answer. Okay. Please check the calculation part. Now, suppose you are having, let me change the color. Suppose you are having the function x, which is again, let me take, depends on the, which is a function of these three independent variable x1, x2 and x3. Then my dear friend, error in x, which is del x, is given by plus minus. Look at the formula very carefully. It is different from the standard deviation. So partial derivative of x with respect to first variable x1 into error in first variable, which is del x1. Remember? So here if you take this as x1, so it will be x1 true plus del x1, like that. Is it clear, Abhishek? All right. And take the mode of it. Take the mode of it. Plus minus. Again the same thing. Partial derivative of x with respect to the next variable, means next independent variable, into error in x2 plus partial derivative of x with respect to next variable x3 into del x3. Done, and close it. So let me inbox this formula, and again it is very important because these are the general formula. Okay. Done. So by the help of this formula, we will going to find our tolerance in the equivalent quantity. So Abhishek, final year. Okay. All right. So here the capital X is this capital R, and we are having only two variable R1 and R2. So using the same concept, let the error in R be del R. Let me change the color. Let the error in capital R be del R. So this is equal to plus minus mod of partial derivative of R with respect to first variable, which is R1, into del R1, close the mode, plus partial derivative of R with respect to next variable, which is R2, into del R2, and close the mode. Done. Okay. Now let me write the derivative directly, otherwise it will going to consume a lot of time. Okay. In the first question I told you how we can find the derivative. Here let me write it directly. So partial derivative of R with respect to R1, keeping R2 as constant, will be getting the expression as R2 upon R1 plus R2 ka whole square. So you can easily remember this formula. First variable we have taken R1, then in the numerator here we'll be having the opposite R2. So what is the equivalent value? Here what is R1 and R2? Here R1 is 10 and R2 is 20. So what is total? 30. R2 is 20, I guess. Yeah, R2 is 20. So we'll get 20 by E Vinod. E Vinod. All right. So 20 by 30 ka whole square, which is again 4 by 9. In the same manner, if you calculate for the next variable, which is R2, see here we are having R2, then here we get R1, and the numerator, in the denominator will be having the same expression, R1 plus R2 ka whole square, like this. So you can directly remember, so that we may save some time in the GATE exam. Now again R1 was 10, R1 plus R2 was 30 whole square. So we'll get this answer as 1 by 9. Excellent. Now substitute this in this formula. This implies del R is equal to plus minus mod of, okay, so del R by del R1 was 4 by 9 into error in del R1 कितना था? Error in del R1, sorry, error in R1 means it is 1 and error in R2 is 2. Close the mode, plus 1 by 9 into 2. चलो देखो क्या आ रहा है, please check it what we are getting, plus minus 4 by 9 plus 2 by 9, 6 by 9. 6 by 9 means 2 by 3, which is 0.67. So let me write it 0.67 ohm. E we know, sir, measurement is not that much weightage in gate, sir. Yes, it is not that much important for double E because of the weightage only. But my dear friend, at the beginning of the session I told you that every marks is important in the gate exam. If you are opting for the rank below 50, like from rank 1 to rank 50, if you are opting for na, then every marks is important for you. Just like the runs in a cricket, हमने देखा है ना कि एक रन से भी मैच हार जाते हैं. We can lose the match by 1 run also. So if you compare the concept of the cricket in our gate exam or in any competitive exam, then you can come to know that how important is every marks. Okay, like this session is not only going to help you in the gate exam, it also going to help you in the other competitive exam. Okay, Vinod, is it clear? All right, so we have got the error in equivalent resistance del R as 0.67. But my dear friend, we need to find the possible values of the equivalent resistance R. So the possible values are, if I say, let me remove this. If I say how we can find the error in the equivalent resistance, then we can find by using this expression R, which is equal to R true plus minus del R. So del R we have already got, which is here. And what about R true? R true is, see, take the individual true value here, R1 true into R2 true. So R1 true was 10 into R2 true was 20, R1 true plus R2 true. समझ में आ गया या कोई डाउट है? Here I have taken the individual true value to get the equivalent true value. So on solving this, what we are getting? 200 divided by 30, 20 by 3, which is 6.67 ohm. So we have got all the values. So from here R, this implies R is equal to 6.67 plus minus del R here. Del R is 0.67 ohm. So what we are getting? We are getting, first take the negative sign, then we'll get 6.00 ohm. This is the minimum value of the resistance including the tolerance or error. Then the next one is 6.67 plus 0.67. What we are getting? So we are getting 7.2344. Okay, I think we are getting this value. First take the negative sign to get the lower limit of R, and then take the positive sign to get the upper value of R. Once you have got the error, then for all the cases your resistance is going to lie within this range where both are included. समझ में आ गया? So R जो है इन दोनों वैल्यू के बीच में होगा. So let us see. Beach in the sense both are included, as I told you. So it is 6 and 7. So option A and option D are the correct option. Alright. Abhishek, it is clear? Sir, how much weightage for measurement in other competitive exam like RRB, JEE, SSC, Transco and Genco? You are from which state, Vinod? Yeah, it is very important. I cannot tell the, like I may not able to tell the correct marks, but it is, yeah, it is having some higher weightage when you compare those with the gate exam. Maybe like 6, 7, 8. I'm not sure about the value, but you can cross verify or you can check from the website itself. Okay. Okay, AP Andhra Pradesh. That is why Transco and Genco you have written. Yeah, I know those are very important. Transco and Genco. Okay, all right. Yeah, for the RRB, SSC, for those exams, this subject is important and it carries some good amount of weightage. Okay, maybe 6, 7 as I told you. So, but please do check. I am not able to remember the exact figure. Okay. All right. So this is the method one, and I know you're finding this particular method to be a difficult one, but let me discuss the same question through the shortcut, which is the method 2. Okay, just a second. Which is the method 2. Okay, I know this method too, most of you will going to enjoy, because this is a kind of shortcut method. Okay, look at here. So equivalent resistance R is equal to R1 into R2 upon R1 plus R2. And please listen me very carefully, because I will going to discuss one very important concept. Now this parallel combination can also be written like this: 1 upon R1 plus 1 upon R2. Okay. Now see, let me take one function P, which is equal to Q plus R. Let me take Q plus R, or Q minus R, where Q is from 1 to 10 and R is from let me take 3 to 5, where both values are included. Now, if you want to find the maximum value of P, then Q should be maximum or minimum. If you want to find the maximum value of P, then Q should be maximum or minimum? It should be maximum. And what about R? R should be minimum. So that maximum minus minimum will give me the maximum value. Got the concept? In the same manner, if you want to find the minimum value, P minimum, then what we can do? Minimum value of Q minus maximum value of R. If you do so, you will going to find the minimum value. The same concept we will going to use here. See, why I have changed this to this expression? Because suppose if you want to find the minimum value, R minimum, then one may think that, sir, take R1 minimum into R2 minimum, and in denominator take maximum, so that minimum by maximum will give you minimum value, na? So R1 max plus R2 max. But how it is possible? You are having this same parameter or variable, and in the same parameter, in the numerator you are taking minimum, at the same time you are taking maximum, which is not correct. Okay, what do you mean by minimum and maximum? See, here we have taken na R1 equal to this. So take first negative sign, we'll get 10 minus 1, 9, and take positive sign, 10 plus 1, 11. Means R1 will vary from 9 to 11. Both are included. So here this R1 value is minimum and this R1 value is maximum. Got the point? So meanwhile, let me find here itself. Just a second. Or else let me write there. Or else let me write here. ठीक है, कोई doubt? So that is why it is very confusing. I cannot able to choose one particular value of resistance. That is why I have changed this particular expression to this. Now here we are having only R1 and R2. Okay. So suppose if you want to find the minimum value, then what it requires? The value of R1 and R2. See, to get the minimum value, numerator should be minimum, denominator should be maximum. When denominator is going to be maximum? When this is maximum or this will be minimum. So R1 minimum plus 1 upon R2 minimum. Got the point? Any doubt? Where, sorry, and in the same manner, R max. How to find the maximum value? When numerator is maximum or denominator is minimum. So कैसे minimum होगा? 1 upon R1 max plus 1 upon R2 max. Excellent. So we have got the concept. Abhishek, Vinod, any doubt? So if you are enjoying the session, please do hit the like button. If you are enjoying the session, please do hit the like button. And so also please share the session link with a friend. So R1, as I told you, it varies from 9 to 11 or 9 ohm to 11 ohm. Similarly R2, ये वैल्यू कितना था R2 का 20 plus minus 2 ohm. So 20 minus 2 18, 20 plus 2 22. So it is 18 ohm to 22 ohm. So this is nothing but R1 minimum to R1 max. Similarly here R2 minimum to R2 max. Done. Substitute in this R minimum to get the minimum value of R, which is 1 upon 1 by 9 plus 1 by 18. So we'll get 6 ohm. You can check by finding this value. Similarly, to get the maximum value, substitute R1 and R2 maximum here to get the R maximum, which is equal to 1 upon 1 by, what is maximum value of R1? 11 plus of R2 22. On solving this, we'll get the answer as 7.34 ohm. 7.34 ohm. Again, you will going to have the same value, 6 to 7.33. As I told you, this is minimum value of R and this one is maximum value of R. So either you can use this method one, which is somewhat lengthy, but those method are in detail and conceptual, and this method 2 is a shortcut one. Okay. So any doubt till this point? Let us move on to the next problem, which is this. All right, and please do use the shortcut method to give the answer very carefully. Okay, and like the fastly, not the carefully, fastly and the carefully too. So let me give you the time. 1 minute, not more than that. Your time starts now. Okay, Abhishek and Vinod, any doubt? Any answer? Okay, we'll solve this question with the shortcut. Okay, we'll solve this question with the shortcut. For the given network, the measurement inductors L1 and L2 have tolerances of plus minus 10% on their nominal values. If the bus current is 20 ampere plus minus 1% RMS, the minimum RMS current through L2, considering the inductor tolerance, considering the inductor tolerances is, and the catch is answer to next nearest integer. And yes, it was asked in gate 23 in mining stream. Okay, mining engineering stream. So whatever answer you are getting, we will have to give the answer to the next nearest integer, not up to, not rounded off to. All right. So see, this is the electrical circuit where this is the source current, you can say I bus current, inductor L1, and this is inductor L2. Now inductor L1, this is 20 millihenry plus minus 10%. So 10% of 20 will be what? 2. So 20 millihenry plus minus 2 millihenry. Okay. This can also be written as 18 millihenry, which is the minimum value, and maximum value is 22 millihenry. Okay. L1 minimum and L1 maximum. What is L2? 5 millihenry plus minus 10%. So this is equal to 5 millihenry. So 10% of 5 कितना होगा? 0.5 millihenry. So 5 minus 0.5 is 4.5 millihenry to 5 plus 0.5, so 5.5 millihenry. So this is minimum of L2 and this is maximum of L2. And what about bus? Like not the bus current, okay, or the source current, which is 20%, 20 ampere plus minus 1%. Plus minus 1%. So this is equal to 20 ampere plus minus. So 1% of 20 is what? 0.2. Okay, so this is written as 20 minus 0.2 कितना होगा? 19.8. And 20 plus 0.2 is 20. Vinod, Abhishek, is it clear? Any doubt? Alright, so we have obtained all the values that is required to solve this question. Now my task is to calculate the inductor current or the current minimum value through L2. So where is L2? This is L2. So I need to find the current here. I hope this color is visible. If not, please do let me know. This is IL2. Now using current division rule, IL2 is equal to total current, which is I bus, into opposite by sum. So opposite is L1 divided by L1 plus L2. My task is to calculate minimum value, means IL2 minimum. So for that, bus value has to be minimum into, again we'll be having the same problem because L1 and L1 we are having in numerator as well as in the denominator. So what we can do, we can write like this: 1 upon 1 plus L2 by L1. Now the thing becomes simple. How? Minimum value कब मिलेगा? When L2 is maximum and L1 is minimum. Okay. So bus value minimum कितना था? 19.8 ampere into 1 upon 1 plus L2 maximum 5.5 millihenry. So 5.5 millihenry, and L1 minimum is 18 millihenry. So on solving this, we'll get the answer IL2 minimum as, let me check, 15.165. 15.165. Okay. So if one may thinking that we have got the values and option A, let us tick it, and we'll be having the full marks. No, you will going to get the negative marks because we need to give the answer to the next nearest integer. And what is the next nearest integer to this? 16. So 16 is the correct answer for this question. So what is the catch? Catch is always read the question very carefully, like up to what value we need to give the answer, whether we need to give the answer up to 1 decimal or 2 decimal or the previous integer or the next integer, like that. Okay? So I hope this question is clear to you. So this is method 1. Method 2 is conventional the previous question we had solved. So the method 2 you can practice from this particular question. Okay, any doubt? Any doubt till this point? Any doubt, my friend? Please do let me know. Here comes the next question. A capacitor C equal to 1 plus minus 0.1 microfarad is charged to a voltage of 20 volt plus minus 1 volt, where errors are in standard deviation. The uncertainty in the charge due to capacitor and voltage is plus minus dash into 10 to the power minus 6 coulomb, round off to 2 decimal places. So here I need to find the uncertainty in the charge due to the capacitor and voltage. So yes, this question belongs to the standard deviation, and the formula we had already discussed in the first question. Alright, so let me give you 1 minute for this. Your time starts now. Do it fast. Any answer? Okay. So see, a capacitor is given as 1.0 microfarad plus minus 0.1 microfarad, which is the true value, plus this time sigma, not del, sigma C, and voltage is 20 volt plus minus 1 volt. So this is true value of voltage plus minus sigma V. Now the charge or the expression of the charge which is stored over the capacitor plate is Q, which is equal to CV, that we all know. Now, so this is capital X. Sorry. So this is your capital X, and this is first variable and second variable. Now, how to find the standard deviation in Q? So let the standard deviation be sigma Q, which is equal to plus minus root over partial derivative of Q with respect to first variable, independent variable, let me say C, into sigma C whole square plus partial derivative of Q with respect to next variable, which is V into sigma V ka whole square. Done. Okay. So partial derivate this equation, del Q by del C will get plus minus root over. हाँ, क्या मिल रहा है? यहाँ मिलेगा V into sigma C whole square plus partial derivative with respect to V, क्या मिलेगा? C into sigma V का whole square. Okay, so this V and this C are the true values. So true value of V is 20 volt. So let us substitute the values plus minus root over, which is 2 into sigma C. Sigma C is 0.1 microfarad. So 0.1 into 10 to the power minus 6 का whole square plus C, the true value is 1 microfarad. 1 into 10 to the power minus 6 into sigma v is 1. Sigma v is 1. And iska whole square. So what we are getting? We are getting plus minus root over. See, this is 2 ka square plus 1 ka square. So it is 5 into 10 to the power minus 12. Because we can take 10 to the power minus 6 ka whole square as common, na? So I have taken that common. So we'll get plus minus root over 5 into 10 to the power minus 12. If you take this out from the root, it becomes 10 to the power minus 6. And this value plus minus root 5 is 2 point, let me check, 2.24 into 10 to the power minus 6 coulomb or minus 6 coulomb. Okay, so what is the correct answer, or what value we need to be feed here? 2.24, which is the correct value. Okay, suppose in the question, if it would have been asked, find the percentage uncertainty or percentage standard deviation, then how we can find? So percentage, like we have got the values. I am talking some extra thing. So you like you may going to get in the GATE exam. Okay. So suppose if I need to find, let me change the color so that we can easily differentiate the solution part. So suppose if I need to find the percentage standard deviation in charge Q, then it is equal to sigma Q upon Q true value into 100%. So in this manner, if the percentage standard deviation is to be find out, then we will be using the same formula. Okay, so sigma Q we already obtained. Now Q true kya hoga? It will be C true into V true. So C true is 1 microfarad. So 1 into 10 to the power minus 6. V true is 20. Okay, तो ये कितना आ रहा है? 20 into 10 to the power minus 6 coulomb. Done. Now substitute in percentage Q. So this is equal to plus minus 2.24 upon 20. 10 to the power minus 6 will be cancelled out into 100%. Okay, let me solve it. So it will be, one is cancelled out, 0, 1.12, so 11.2% plus minus. Okay, so this is the percentage standard deviation in the Q. Always look for the units, whether the question is given in coulomb or percentage. With respect to that, we need to find. So for this particular question, our answer is 2.24. But if the question was with respect to the percentage standard deviation, then in this manner we will going to find it. ठीक है? Any doubt? Is it clear, everyone? Let us move on to the next question. Okay. So we are done with the all the concept from the chapter 1. Let us move on to the chapter 2, which is measurement of voltage and current, which is also known as basic quantity, measurement of basic quantities. And what are the important topics? Permanent magnet moving coil instrument, which is PMMC. Extension of the range in voltmeter and ammeter in PMMC. Moving iron instrument. Extension of range in voltmeter and ammeter in moving iron instrument. Alright, so let us see the first question. So this is the first question. In the given circuit, ideal voltmeters are placed one across capacitor and another across diode as shown. Then identify the correct reading. So this is the basically the electrical circuit we are having, and we need to identify what are the readings of V1 and V2 that we can choose from the options or the correct reading. So basically this question belongs to the combination of your network, power electronic and the measurement. Alright. So let me give you the 3-minute time for this, not more than that. 3 minutes. Your time starts now. One minute remaining. Do it fast. Abhishek, Vinod, everyone. Any answer? Yeah, see, the number of views are very high, but still the likes are very less. Please don't do such kind of what to say, like this is not good basically. Okay, I am here to help you out in every possible manner. I will going to help you out, but at least do hit the like button, which I want from your side only. Okay, so this thing you can do, I know. Chalo, what is the answer? So this is MSQ type of question, multiple select question. So please let me know what is the answer. All right. So see, we need to find the reading of V1 and V2. So if you see, V1 is MI, means moving iron voltmeter, and V2 is PMMC, permanent magnet moving coil. Now before heading towards the solution part, let us discuss some basic concept related to the MI and PMMC. Okay, so permanent magnet moving coil, what kind of voltage or current it can measure, or what kind of quantities it is going to measure? It will measure DC quantities, average quantities, or RMS quantity. What PMMC measure? So PMMC, permanent magnet moving coil, it measures always average DC mean. All are same. Okay, and moving iron voltmeter, it measures RMS value. Done. Suppose you are having any function f of t like this. Let me change the color. Suppose you are having any function f of t like this, f0 plus f1 sin omega t plus f2 sin 2 omega t plus so on and so forth. So basically this is a Fourier expression of certain function. Now your PMMC will measure this particular function as f0, and in the same manner, means the average value of f of t is what here? F naught. And similarly, if the instrument is mi, it will going to measure f naught ka square plus f1 square plus f2 square plus so on so forth whole divided by 2. So if any function is given in terms of this Fourier series, we can directly find its value, average value and RMS value, which I already written over there. Done. Okay. So see, this is the circuit and this is your supply, this is one diode and this is one capacitor. So basically your moving iron will measure the diode voltage and your PMMC will measure the capacitor voltage. So let me draw the circuit here. So this is one diode, then we have the capacitor, this is the voltage source, okay, and we are having the moving iron over here, I guess, and we are having the PMMC. Let me take MC. Okay, so this voltage was V1. Let me check. Yeah, V1, and this voltage was V2, and this is 1 microfarad. Done. All right, so let me take the diode voltage as plus minus VD and capacitor voltage as plus minus VC. And let us take the current here, which is flowing as IS from the supply, and your voltmeter are ideal, means no current will flow through the meters. So whatever current which is coming from the supply, it will go through the diode and through the capacitor, and it will get back into the supply. Okay, so let me take the current here, diode current, as IC. Done. Okay. Now the working, or let me take the supply voltage, just a second, let me take the supply voltage as Vs, which is Vm sin omega t. Okay, it is a sinusoidal. Let me take Vs is Vm sin omega t. All right, done. Okay, so case 1, like here I will going to show the working of this particular electrical circuit in 2 cases. The first one is the positive half supply, when the sinusoidal value of the voltage or the voltage of the sinusoidal value are positive, which is case 1, and we know that it is positive for omega t from 0 to pi, है कि नहीं? 0 से pi पे ये positive होगा. But my dear friend, again under this we will be having 2 more cases. In the case 1 itself, we are having 2 more cases. So case the first is from 0 to pi by 2. Why I have taken the 2 cases, you will come to know once I will going to conclude the case 1. All right. Now in the case 1, please listen very carefully. In the case 1, the supply voltage is positive. Therefore, current IS will flow in this direction. Done. Now the diode direction and the current direction from the supply, both are same. It means that diode will conduct. And whenever the diode is conduct, and if the diode is ideal, then diode will behave as a short circuit. Got the point? So the same circuit I can draw like this. Here let me do the changes. Sorry, get stuck. Okay, which color should I take? Let me take white color. I hope this is visible. Okay, so this is short circuit. So diode is shorted. Okay, so once the diode is shorted, can I say your supply voltage, means this is plus, this is minus. So the supply voltage Vs is nothing but your capacitor voltage, or it is better to write capacitor voltage is equal to supply voltage. है कि नहीं? Apply KVL here. So your Vs is nothing but Vc, or Vc is nothing but Vs. Then let us find the current IC, supply current or the capacitor current. Both are same here because both are connected in series. So what is the equation of IC? C dVc by dt means capacitor voltage and voltage across the capacitor Vc. So Vc कितना है यार? C d by dt. Vc is Vm sin omega t. So let us differentiate. We'll be getting C Vm omega cos omega t. Let me take this quantity as maximum value. Im cos omega t. All right. So we have obtained the value. Now listen me very carefully. From 0 to pi by 2, your capacitor, do I have a space? Just a second. Just a second. Let me reduce the size. Okay. So let me mark the axis. Please wait. Let me mark the axis. So yeah, VD. I need VD, VC, and Vs. Sorry, VD, IC, and okay, all right. Please wait, let me draw the axis. Okay, so this is Vs against omega t. The second axis is of Vd against omega t. Then this is Ic against omega t. Next is capacitor voltage Vc against omega t. Okay, so here Vm, ये रहा Vm. What is this Vm value? Vm is √2 into RMS value. So this is your RMS value. So let me write here Vm, where Vm is √2 into VRMS. यही लिखते हैं ना for the sinusoidal. RMS क्या लिखते हो? Vm by √2. So Vm is √2 into VRMS. So which is √2 into 230 volt. Okay. So let me change the color. So this point is, sorry, this point is pi by 2 and this point is pi. First, I am only going to discuss about this portion, this span. Okay. So supply voltage here is positive, like this. After that, it will going to reduce, है कि नहीं? Sinusoidal. So let me draw it for convenience. It will be like this. This is a sinusoid. ये visible है ना? All right. Now VD under this case 0 to like 0 radian. This is 0 degree to pi by 2. VD is shorted. It means that it will be 0 volt, like this. It will be 0 volt. Next, what about IC? See, IC is Im cos omega t. So at omega t, it will be maximum, which is at Im value. Let me use different color, sorry. This is Im. So cosine waveform is like this. Cosine waveform is like this. Now what after this? If you see carefully, after omega or after omega t at pi by 2 plus, like any value greater than pi by 2 will make the capacitor current to be negative. है कि नहीं? What do you mean by negative current? The direction of the current is going to be reverse. Got the point? The direction of current is going to be reverse. What it means? It means that as soon as the direction of the capacitor is going to be reverse, the diode is going to be open circuit, because diode will not allow the opposite current. Therefore, at pi by 2 itself, the diode is going to be open. The diode is going to be open. So my dear friend, due to this capacitor current, your capacitor is going to be charged because it is following Vc equal to Vs. So capacitor is going to charge. Let me change the color. Capacitor is going to charge like this. And what about this value? What about this value? This value is Vm and this value is again Vm. क्या ये समझ में आ गया सबको? Any doubt? Now let me discuss about the next portion, which is pi by 2 to pi. So second, not the case, the second point means pi by 2 to pi. So let me draw the figure. As we come to know that the diode is going to be open because capacitor current is reverse of that of the diode. This is your supply, which is Vs. This is the capacitor. This is voltage V2, which is PMMC. Capacitor. This is plus minus Vc. This is plus minus Vd. And here you are having the voltage V1. Like this. Done. Okay. Now what about the current in the circuit? Is, it will be 0 ampere, or IC, capacitor current, again it will be 0 ampere because your circuit is open circuit. Therefore, your capacitor is not going to charge here onwards because there is no element to charge the capacitor or to discharge the capacitor. What it means? It means that your Vc is going to stuck at Vm because at pi by 2, what is the value of Vc? It is Vm, and after this it will not going to discharge because circuit was open circuit. Next, IC current, it will be 0. Next, your Vd, अच्छा Vd क्या होगा? Vd, apply KVL in this loop. So it will be, let me write, minus Vs, this is plus minus Vs plus Vd plus Vc, which is equal to 0. So what is Vd, my friend? Vd is Vs minus Vc. What is Vs? Vm sin omega t, and we know that Vc is now fixed to Vm because it will not going to discharge further. Sorry, it will not going to charge further. So we can write Vm as sin omega t minus 1. Okay. So again, let me have some space. Is circuit visible? Is circuit visible? Okay. Just a second. Please wait, let me mark the axis. So this is pi by 2. This one is your pi. Okay. So this is pi by 2 and this one is your pi. So this is Vs against omega t. Next, what we had written, Vd, Ic, Vc. So this is, let me write Vd here, na. So I have taken this as Vd. Next, IC, let me take here, and VC, let me take here. Let me take one more reference like this. Okay. So let me draw the figure first. This is Vs and this point is Vm, है ना? This point was Vm. Okay, and we know that at pi by 2 to pi, the capacitor current is 0. So here we can directly draw like this. Okay, which color we had taken for this? Brown one. Okay. So it will be 0. IC will be 0. Next, what about VC? For VC, which color we had chosen? कहाँ गया VC? VC ये रहा. Okay. Now we know that since there is no element to let it discharge or charge, so therefore VC is fixed to Vm. to Vm. This is Vm value. This is Vm value. And what about diode voltage? Earlier it was 0. Earlier it was 0. Now from pi by 2, look at here, from pi by 2 to pi. At pi by 2, what is the value? 1 minus 1, 0. At pi, it will be 0. So 0 minus 1 minus Vm. So it will start from, let me take, okay, या क्या color लिए थे हमने? For VD we have chosen green color, ना? ठीक है. So it start from 0. क्या हुआ ये? From 0, it will go like this. So this is 0 volt and this is minus Vm, and let me take this is minus 2 Vm. This is how the circuit or the waveform will look like under 0 to pi by 2 and pi by 2 to pi. Now let us discuss the case 2. Case 2 means at omega t from pi to 2 pi. So from here we need to draw the circuit. Now at pi, what is the capacitor voltage? Again Vm. What is the capacitor current? 0. And what is Vd? Vd is minus Vm. Now please listen me very carefully. At pi or at omega t equal to pi plus, like 181 degree, 182 degree, what is this supply value? Can I say it will be reverse? Means plus यहाँ पे आ जाएगा, sorry minus यहाँ आ जाएगा and plus यहाँ पे आ जाएगा. Now whether your diode is going to on? No, it will not going to on, because see minus plus and here you are having Vd. So this two value is going to be added up to give this Vd. नहीं समझ में आया मैंने क्या बोला? Look at here. Let me take this as plus minus Vs. What I am doing for the case 2 from omega t equal to pi to 2 pi. So let me remove this. Minus Vs plus Vd plus Vm. This is the expression which is again valid for the pi plus. Okay, what is Vd? Vd is Vs minus Vm. Vm is capacitor voltage. Now at pi plus, what is this value, my friend? It will be negative at pi plus, because Vs is Vm sin omega t. So it will be negative, and this is anyway negative. So negative is always negative. So at pi to means at pi to 2 pi, from pi to 2 pi means at negative half cycle, this supply voltage is always negative. So therefore the equivalent value is negative, and hence diode is off or reverse bias. So the same equation or the same circuit or the same waveform are valid for the case 2. So let me rub this. So in the case 2 itself, as supply voltage is negative, therefore diode will never be getting on, and hence it is reverse biased or open circuit. It is reverse biased or open circuit. So this implies your capacitor voltage is again stuck to plus Vm. IC value is 0. And what about Vd? Equation will be same. Vm sin omega t minus Vm. So this is capacitor voltage. So I can simplify like this, Vm sine omega t minus 1. Okay. So let me make the complete figure now. So do we have the axis here? I already have the axis. Or meanwhile, let me draw the figure for my convenience or for your convenience. Just a second, I will not going to take a much time. We are about to complete, please wait. So this is pi by 2 axis, this one is pi axis, this is 3 pi by 2 and this is pi. All right. So Vs omega t, next it was IC, VC, VD. IC, VC and VD. Okay. So this is 0 degree, pi by 2, it is pi, it is 3 pi by 2 and it is 2 pi. Okay. What about IC? IC ka brown, then sky blue. Okay, just a second. So again it is 0. Then for VC, it will be again Vm. And for VD, just a second, for VD, let me mark the axis. I know it is taking time to draw the axis and all those things, but it looks better and it helps us to understand the waveform in very crystal clear manner. Okay. So green one. Okay. So this is minus Vm. This is minus 2 Vm. So yeah, from pi by 2 to 3 pi by 2, it will follow the curve like this. After this, sorry, like this. So this is how your capacitor voltage and current and your diode voltage looks like. ठीक है? See, at 3 pi by 2, which is 270, it will be minus Vm. Sorry, at 270 it will be minus 2 Vm, because this is minus 1. Minus 1 minus 1 is minus 2 Vm, which is what I had written, 3 pi by 2. Done. Now let me make the complete figure. Let me make the complete figure. So like see, every section is 90 degree, na? Nice teaching, sir Sandeep. Thank you for the appreciation, Sandeep. So every section is pi by 2, 0, 90 degree, 180, so on and so forth. So let me draw the Vs first. So this is Vs against omega t, and this is plus Vm maximum value, and this is the capacitor this is the diode voltage. Vd against omega t, because your voltmeters will read, the capacitor voltage and the diode voltage. Because of that, I'm going to draw only the capacitor voltage, not the current one. Okay, that IC current or the supply current that we had already discussed. Okay, so let me draw the capacitor in the same axis, like here. Vc, capacitor voltage. Okay, we know that from 0 to pi by 2 it will going to follow the supply voltage, and after pi by 2 it is always, let me choose the straight line. It is always going to be straight line like this. Any doubt? Any doubt? So this is your Vm, which is the capacitor voltage. First, initially it will follow this, it is pi by 2, this is pi, this is 3 pi by 2, then 2 pi, then 5 pi by 2, 6 pi by 2 means 3 pi, 7 pi by 2, and 8 pi by 2 means 4 pi. So 2 cycle of supply I have drawn here. Okay, now the diode voltage, this is minus Vm, this is minus 2 Vm, this axis. Okay. So initially it was 0, from 0 to pi by 2, and after this it will follow like this, it will follow this curve. ठीक है, so ये क्या है आपका, this voltage is plus, so this voltage is plus Vm, and here this voltage is what, Vm, diode voltage. Diode voltage is Vm sine omega t minus 1. That is what the curve says. Now our task is not yet completed. So let us first find the diode, the capacitor voltage, and capacitor is connected across PMMC, and PMMC reads the average value. Okay, so what I need to do, I need to find the average value from the first waveform, and to get the average value or RMS value, steady state has to come. We cannot apply the formula directly in the transient to get the one value. Okay, so here where is the steady state we are getting? From 0 to pi by 2 it is a steady state? No, from pi by 2 to 5 pi by 2, if you see, here the cycle is going to be repeated. So this is one steady state. So in this particular of cycle, or at one cycle, I will going to apply the formula. Now since capacitor is connected across PMMC, and we know that it is going to measure the average value. So Vc of t, how to find the average value? 1 upon t integration over one time period, Vc of t d omega t. Let me write in terms of omega. Quit out. This is how we can find the average value. Now my dear friend, omega t is one cycle. So what is one cycle over here? From pi by 2 to 5 pi by 2, which is 2 pi. Integration from pi by 2 to 2 pi. What is the value of capacitor? It is plus Vm into d omega t. So when you solve this integration, we'll get plus Vm, and plus Vm is root 2 into 230 volt. So let me find the value here. So this is 325.27. 325.27 volt. Done. Next, like we have got the reading of capacitor, and this reading was for the voltage V2, I guess. So this is V2. Now let us find for the V1, which is the diode voltage, and diode is connected at Mi. So it will measure RMS value. Now how to find the RMS value if we are having the waveform? So Vd of t RMS, this is equal to 1 upon omega t root over 1 upon omega t integration over one time period into Vd of t का whole square d omega t. Okay, so please remember this formula and this one. I like this formula and this one. This is for average value and this is for RMS value. All right. So substitute all the values here. 1 upon omega t is 2 pi. Integration from pi by 2 to, okay, extremely sorry. This is not 2 pi, this is 5 pi by 2. Okay, one time period की बात कर रहे हैं ना, from pi by 2 to 5 pi by 2 and 5 pi by 2, which is Vm sin omega t minus 1 का whole square d omega t. Okay, so I am not going to solve the complete integration. I hope you are knowing this. All right, so let me write the result. So the value here, like the final value which we are going to get, is root over 3 by 2 into Vm, and Vm is root 2 into 230. Vm is root 2 into 230. So root 2 will be cancelled out. So root 3 into 230 volt, which is equal to 398.37 volt. 0.37 volt. So your V1 is 398 and your V2 is 325. So V1 is 398, which is given in option C, and your V2 is 325, which is given in option B. So option B and option C are the correct option for this question. So कैसा रहा question? I know it is difficult to digest because we are having a lot of things, and I already told you that this question is a combination of network, analog and your measurement. So the combination of three subjects concept, I have framed this particular question. All right. So definitely you will not going to get such kind of lengthy problem at only the part of this you will going to have in the GATE exam. All right, let us move on to the next question that we are having. A moving coil instrument having a resistance of 5 ohm gives a full scale deflection when the current is 50 ampere. What should be the value of series resistance in ohm so that it can be used as a voltmeter for measuring the potential difference up to 250 volts? So this question is basically related to the extension of the range of the PMMC meter. Okay, so look at here. Initially what we have, meter resistance Rm, which is 5 ohm, and maximum current which can be measured is 50 milliampere. So if you see, this is the resistance and this is the needle of the PMMC. So this resistance is basically inside of this meter, but to show you how the resistance is going to be measured, I have kept this to be outside. Okay, but always understand that the resistance is always inside this meter. Okay. So this is your Rm, and the current here which is flowing as Im. So this is the case when the range was not extended, So let me mark the point as A, like this node as A and this node as B. So what is the voltage that it actually measuring when the range was not extended? कितना होगा in terms of voltage? कितना होगा? So this is plus minus. So this voltage is Vm is equal to Im into Rm. यही लिखते हैं ना? Im is 50 milliampere, Rm is 5. So 50 into 5, 250 millivolt, which is nothing but 0.25 volt. Any doubt? So with this value of current, the maximum voltage that voltmeter can measure without the extension of the ranges is 0.25. Now in the question it was said that you have a Rm which is 50 ohm, I guess. No, sorry, 5 ohm, and you have the pointer like this. Now by adding the resistance, we know that the voltages can be increased. So let me take this resistance as RAC. So once you add this resistance, your total voltage, let me take VEX, is now extended to 250 volt. 250 volt. So what should be this resistance? Okay. So it was 0.25 volt till this point. Okay. So this was A. Let me write here. This was A point. Here it was B point. So let me take this time B dash, the new point. Means here you have added one resistance such that this voltage is now extended to 250. Techno VD, hi Techno VD. Now once you have added the resistance, can it able to change the maximum current which was flowing through this meter? Whether the maximum current is going to change. If you are thinking that the maximum current is going to be changed, then you are wrong, because this maximum current, if it is going to exceed na, this meter is going to be damaged. This meter is going to be damaged. Therefore, if you add the resistance, or even if you are not going to add the resistance, the maximum current that it can be measured is IM. ठीक है? So let me write here IM, which is 50 milliampere. Done. All right. So this is 250. This is 0.25. So what is this voltage, my dear friend? 250 minus 0.25. Okay. So can I say RSE is equal to this voltage, which is nothing but VEX minus VM. देखो ये VM है 0.25 whole divided by current was IM. Okay. Techno not change. Excellent techno. Excellent. So please remember, it is very important. Even if you add the external resistance to extend the range of the voltage, your maximum current will remain same. Okay, so this is 250 minus, ये माइनस है ना यहाँ पे 0.25, यहाँ स्पेस नहीं था इसलिए मैं वहाँ लिखा नहीं हूँ, माइनस यहाँ लिख दिया मैंने, डिवाइडेड बाय 50 मिली एम्पियर, आई गेस 50 मिली एम्पियर. So when you solve this, you will get the answer as 4995 ohm. This is the method 1, which is the conventional method. Okay, I hope you have understood this method very carefully. This is method 1. Method 2 is shortcut, and one who knows the formula, they can easily solve. How? Method 2, let me write here. Method 2. Like if you remember the formula of RSE, which is RM V by Vm minus 1. Here V, in this case V I have taken as VEX. Okay. RM is 5 ohm. Vx is extended voltage 250 divided by Vm is the maximum voltage before the extinction 0.25 minus 1. So from here also you will going to get the same answer as 4995. So those who knows the formula, they can get the answer in the 3 step, or those who are not knowing the formula or not able to remember the formula, they will going to proceed in this manner. Alright, so I have given both the method, so you can solve the question from any of the method. Definitely you will going to see at one question in gate 24. It is my word. Alright. So let us move on to the next, which is the measurement of power. So this is the important topic under this, measurement of 3-phase power using 2 wattmeter. The remaining topic you can skip. This is the first question. A wattmeter reads 400 watt when its current coil is connected in red phase and pressure coil is connected between red phase and neutral of a symmetrical 3-phase star connected balance load of 0.8 power factor lagging. The phase sequence is RYV, means the positive phase sequence. What will be the reading of the wattmeter if the pressure coil alone is connected between black and yellow phases with all other connection remains unchanged? So here we are going to have the 2 case. Case 1. When pressure coil is connected between R phase and neutral, and current coil is connected in which phase? In red phase. In red phase. It means that here it is going to measure the single phase power, because the voltage is phase, like see, line to neutral means it is a phase voltage, na? So it is going to measure the phase voltage. So the power that it is measuring is 400 watt. Done. Now my dear friend, what is the single phase power? VPH. Let me take the per phase power as VPH. Like the per phase voltage, VPH, per phase current, IPH is equal to cos phi equal to 400 watt. This is what the real power. This is what your real power. Cos phi is the power factor which is given in the question as 0.8. So VPH, IPH is 400 divided by 0.8 which is the power factor. क्या value आ रहा है ये? This value is 500 volt ampere. This is apparent power basically. This is your major single phase voltage. Excellent. Because of this connection, pressure coil is connected between rate phase and neutral. So this is your apparent power. Now my dear friend, in the second case, let me write here. In the second case, any answer? Any guesses? Any answer? In the second case, your pressure coil is alone connected between black and yellow. Your pressure coil is connected between black and yellow phases, whereas current coil remains unchanged, means it is connected in R phase. You are getting 500, but it is not in the option techno. Please check. Now, please listen me very carefully. When the pressure coil is connected between the two lines, whereas current coil is connected only the one line which is the remaining line. See, R Y B. आपने B and Y को प्रेशर कॉइल में ले लिया, बचा क्या? R phase. So in such cases, your wattmeter will read VL IL sin phi. VL IL sin phi. Please do not get confused with P. It is just a notation. I can use my name, Nikhil, I can use here. I can write Nikhil here. It is just a notation. Now, VL is the line voltage, IL is the line current and sin phi. VL line voltage. See the connection. It is star. Somewhere it is written. No. It is written star. Okay. I think it is not written. But anyway, if connection is not given, by default we will take star connection. By default we will take star connection. So, in star connection, your line current and phase current both are same. And your line voltage is √3 times of phase voltage. And as I told you, line current and phase current both are same in star connection and sin phi. So √3 into VPH IPH is 500 into sin phi. How to get this sin phi? Remember, in the mensuration, in the trigonometry, we know this relation, sin square theta plus cos square theta is equal to 1. Instead, in our case, instead of theta, we have used phi. So, sin square phi plus cos square phi is equal to 1. Cos phi is 0.8. So, from here, sin phi is 0.6. So, sin phi is 0.6. So, this value is coming out to be as 519.6. Now, which is not correct? Definitely option C and option D are not correct. Then, which is the correct option? It is watt or volt ampere rating. This is the real power and this is the reactive power. Whenever you are having this kind of connection, my friend, whenever you are having this kind of connection, it will always measure reactive power. Please, again I am saying, please do not get confused with this notation. I can use anything here. Now, how I come to know that it will going to measure the reactive power? By using this expression, VL IL sin phi. What is real power expression? VL IL, like √3 VL IL cos phi. What is reactive power expression? Root 3 VL IL sin phi. So here, forget about root 3 here, that root 3 term is missing, but it is for sure that it is going to measure the reactive power. It is not going to measure the 3-phase reactive power, but definitely it will going to measure the reactive power. Okay? So therefore, I have written here as reactive power. So what is the unit? VAR, volt ampere rating. So the correct option for this question is option B. Any doubt? Techno, Abhishek, Sandeep, Vinod. All right. Let us move on to the next question, which is this one. The power input in a 3-phase 3-wire star connected balance load is measured by 2 wattmeter method. The reading of wattmeter A is 5000 watt and wattmeter B is minus 100 watt. If the voltage of the circuit is 440 volt 50 hertz, what element should be connected such that both wattmeter will always show positive reading? Okay. So here wattmeter 1 is measuring 5000 watt and wattmeter 2 is measuring minus 1000 watt. Done. So what is power factor angle? It will be tan inverse root 3 P1 minus P2 upon P1 plus P2. Okay. So substitute this value in this expression, you will get the phi value as, let me write it directly, phi value is as 68.95 degree. 68.95 degree. So this is nothing but your load impedance. This phi is what? Power factor angle. And what is power factor angle? The angle difference between the load voltage and the load current. So the load voltage here by default is taken as a reference, which is the 0 degree. So whatever angle you are having for the impedance is also going for the current. ठीक है, मैं ये कहना चाह रहा हूँ, suppose you are having this impedance like Z at an angle theta. This is in complex. This Z is magnitude at an angle theta. And this is voltage VPH and current here is IPH. If voltage is reference V at an angle 0, then this divided by this IPH is equal to V at an angle 0, Z at an angle theta. So can I write magnitude of IPH at an angle minus theta? So that is what I told. Whatever angle you are having for the impedance, the same is going for the current as well, if this voltage is reference. So my dear friend, let me rub this, it is not required. So my dear friend, this 68.95 is what? Lagging power factor. And what do you mean by this? It means that your load is having the resistance as well as inductance. So this is R, this is plus J XL. So together this means tan inverse XL by R. This is nothing but your power factor angle, that what we have obtained here. Done. Now if you see here, 1 wattmeter is showing negative reading, and it is only possible if your power factor angle is greater than 60 degree. What it means? It means that your power factor, your meter will read, or meter will show the positive reading if power factor angle will be 60 degree. If power factor angle will be 60 degree. Got the point? So for both wattmeter to read positive value or to show positive reading, then the power factor angle should be 60 degree. Please remember this point, should be 60 degree. Now earlier we are having 68.95. This has to be reduced to 60 degree. Now how it will going to reduce to 60 degree? If you add more inductance or if you add the capacitance. If you add the inductance, this imaginary term is going to be increased. Therefore, phi is going to increase further. But we want ulta. It means that if you add the capacitor, the reactive element is going to be reduced. Therefore, phi is going to reduce to 60 degree. So, in the impedance, what you need to do? The resistance that we have, inductance which we have plus jXL. If you add the capacitance which is minus jXC, then your phi will become tan inverse XL minus XC by R. है कि नहीं? But to show the positive reading, what should be the power factor? It should be 60 degree. Then what should be the capacitance value? It will be tan inverse XL is omega L minus 1 by omega C whole divided by R. Do we have anything do we know anything about omega L or R? Means the L and R, not the omega, L and R. No, we don't know. But we know omega. Omega is 2 pi f, frequency is 50 Hz. So 100 pi. We know the omega. But how to get L or R or XL or R? We can easily get. How, sir? See. See, please listen the lecture very carefully. I am going to discuss very important point. See, the real power, let me change the color. See, the real power P is equal to P1 plus P2, which is 5000 minus 1000, which is 4000 watt. Now, since this is the three-phase power, na, so three-phase power is root 3 VL IL cos phi, which is 4000 watt. Root 3 into it is a star connection, and we know that in the star VL is root 3 times of VPH, and line current is phase current in star cos phi equal to 4000 watt. So 3 VPH IPH cos phi equal to 4000. Cos phi is 0.8. It is already given in the, no, cos phi is not 0.8, but we can find cos phi. Sir, these are also star. Yeah, this is all, it is already mentioned, star connection. Take note. All right. So yeah, but we can find cos phi. Phi is 68.95, na? So 3 into VPH IPH okay, VPH is already given in the question, no? I think voltage is given. See, a voltage is 440 volt. This is line voltage. What about phase? Phase will be 400, or let me make it clearly. Sorry for this. I have rubbed those part because VL is already given in the question. It is 440, है ना? It is 440 into IL is IPH because of the star connection. Cos of phi is 68.95 degree. which is equal to 4000. So from here, what is IPH, my friend? This IPH is, I am having the value 14.613. Everybody please check, 14.613 ampere. Done. So we are having the load like this. है, मैं इसी लोड की बात कर रहा हूं. See, this is impedance per phase. Star connection है ना, so one phase, second phase and third phase. So one phase will have this ZPH. So here the voltage is VPH and current is IPH. Voltage is VPH, current is IPH. So can I say this is ZPH, current is IPH and voltage is VPH. So can I say the magnitude of ZPH will be what? Magnitude of ZPH will be what? VPH divided by IPH. VPH is 440 by root 3. है कि नहीं? Line voltage is root 3 times of phase. So phase is line divided by root 3. Line divided by root 3. And I phase we had already calculated as 14.613. 14.613. So on solving this, you will get the answer as impedance 17.384 ohm. So this is the impedance. So RPH, this will be ZPH into cos phi. Remember? लिखते ना R equal to Z cos theta. R equal to Z cos theta. So we have ZPH, we have cos phi. Phi is this value. So substitute both value here. You will get RPH as, let me write it directly, 6.244. 6.244 ohm. Any doubt in this, techno and everyone? What about XPH? It will be ZPH sin phi. मैं इसकी बात कर रहा हूं, impedance triangle diagram. This is phi. Base is always resistance. Perpendicular is always reactance, and this is impedance. Any doubt, techno? Vinod, everyone? So this is equal to 16.224. 16.224 ohm. So let me rub this, it is not required. Now we have got all the values. So this XPH is nothing but XL. That is what we have taken, XL. Okay. Now substitute here. Now we have obtained all the values, substitute here. So phi is 60 degree, tan inverse. XL we have obtained as 16.224 minus XC. XC is 1 upon omega C. Omega is, yes sir, right angle triangle. Excellent that you are knowing this particular concept. Now XC is 1 upon omega C. Omega is 100 pi. 100 pi into C. 2 pi F है ना, 2 pi F, F is 50, so 100 pi divided by resistance. Resistance कितना है? 6.244. So we are having only one unknown, which is C. On solving this, you will get the capacitor value as 588.47 microfarad, which is given in option D. So option D is the correct option for this question. Any doubt? So let us move on to the next chapter, that is chapter 4, which is bridges. So these are the key topic or the important points, the important topics. From here you can going to get at least one question in your GATE exam. Alright. So let us move to the first question under this. An unbalanced AC bridge is shown in the figure. What maximum voltage in magnitude can appear across detector for X belongs to minus 1.5 to plus 1.5, assume ideal voltmeter. So we need to identify what should be the maximum voltage of this particular detector. All right. So here this question is basically the combination of your mathematics and measurement. All right. See, this is your circuit. Let me change the color. This is your circuit. Let us have the detector voltage as plus minus Vd. And this as, here the current as I1, here the current as I2. Sorry. Okay. So the capacitor voltage is plus minus, let me take Vc1, and here capacitor voltage is plus minus Vc2. And since the detector is ideal, therefore no current, or it is balanced, kya kuch diya kya? No, it is unbalanced. So since the detector is ideal, it means that it is going to have the infinite impedance. So means no current is going to flow here. It means that ID is, detector current is 0 ampere. Detector current is 0 ampere. Now apply KVL in this loop. ये जो inner loop है ना यहाँ पे, इस पे. So plus Vc1 plus Vd minus Vc2 equal to 0. Done. So what is Vd? Vd is Vc2 minus Vc1. Now apply voltage division rule. Here see, this I1 current, these are same for this capacitor as well. So we can directly apply the voltage division rule. How we can apply? Across this branch, what is the voltage? Supply voltage. See, in this branch, supply voltage. So how we can write the voltage division rule for that? E, that is the supply voltage, into, I am writing for Vc2. I am writing for Vc2. For this, I am writing for this. So E into opposite impedance, which is having the value capacitor. Like capacitor में उल्टा चलता है ना, capacitor में उल्टा चलता है. In to apply the voltage division rule. So we are finding Vc2 means here this value. Here the current are in series. So आप इसका find कर रहे हैं, तो आपको ये capacitor value लेना है, उल्टा चलता है. By sum. So C into 1 plus X plus C minus Vc1. What is the voltage? Total voltage here E into. So इसका उल्टा C times of 1 minus X upon sum C plus C1 minus X. Done. चलो देखो क्या मिल रहा है. C will be cancelled out, so we are left with E upon 2 plus X. एक बार चेक करना. E upon 2 plus X minus E 1 minus X upon 2 minus X. Now simplify this. I have the value. Okay, what we can do one thing. Okay, ठीक है. Let us simplify it. E times of. Take the LCM. I have taken E outside. Take the LCM. 2 minus X minus 1 minus X 2 plus X. And at the denominator we are having A plus B, A minus B, which is 2 का square means 4 minus X. जरा simplify करो. E times of 2 minus X. Next. माइनस यहाँ पे क्या मिल रहा है? 2 प्लस एक्स माइनस 2x प्लस एक्स माइनस 2x. एक बार चेक करना यार, कहीं गलत ना हो जाए. 2 प्लस एक्स माइनस 2x माइनस एक्स स्क्वायर whole divided by 4 minus x square. So E into, हाँ क्या मिल रहा है, 2 minus x minus 2 plus x minus 2x minus x and this minus plus x and here minus x square. 4 minus x square. जरा चेक करो एक बार, सॉरी प्लस एक्स स्क्वायर इट विल बी. सही है क्या टेक्नो एंड एवरीवन? 2 minus x minus 2 minus x, this minus plus x and minus minus plus x square. All right. So it will result the final expression as x square upon 4 minus x square. Now to get the maximum value of diode of the detector voltage, what we need to do? We need to differentiate. Remember in the mathematics how we can find the maximum value of a particular function? Differentiate. This is Vd, just a second, this is Vd. Differentiate with respect to the independent variable. So differentiate del Vd with respect to x. हाँ क्या मिल रहा है? E. It is u by v form. So 4 minus x का x square का whole square in the denominator. Okay. So left the denominator, differentiate numerator 2x minus left the numerator, differentiate denominator 0 minus 2x. क्या मिल रहा है यहाँ पे? E times of 8x minus 2x square, sorry 2x cubic, 2x cubic minus minus plus 2x cubic upon 4 minus x square का whole square. Okay. So क्या मिल रहा है final expression? It will be, this is cancelled out, E times of 8x upon 4 minus x square whole square. Now equate this to 0. So del Vd by del x equate, sorry, not partial derivative, it has to be derivative, na? So different equate it to 0. So once you do so, we'll get x as 0 value. So from here Vd at x equal to 0 क्या मिल रहा है? देखो Vd at x equal to 0, this is Vd expression. So at x equal to 0 it is 0 volt. But if you're going to tick this option C, your answer is going to be wrong, because whenever the range is given, then at the extreme end always find, the Vd value or the function value at that extreme point. Okay, so let us find here. So Vd at x equal to minus 1.5. So E times of minus 1.5 का square whole divided by 4 minus x square, which is minus 1.5 का whole square. On substituting the E, which is 1 sin 314t, you will get the answer as 9 by 7, I guess. Let me check. 9 by 7 sin 340t. Okay. 0. Sir, answer B आएगा. No, answer is not going to be B. Because see, let me add a page. See, here this is your extreme point. So at this point your diode voltage can be maximum or minimum. It can have both the values, like not the both, it can have any of these two values. But how to check whether this is maximum or minimum? Again, double differentiate here, means here, and equate x equal to 0. Okay, let me add a point. See, del square Vd by del x square. If you again differentiate here, which is E times of let me write E times of, let me differentiate, let me take it outside because it won't affect the derivative. So 4 minus x square का whole square into ये differentiation is 1 minus, now left the numerator x, now differentiate denominator, what we are going to get, first differentiate this, so it is 2 times of 4 minus x square, done. Now differentiate this again, 4 minus x square, which is 0 minus 2x whole divided by 4 minus x square का whole square. Just a second. ओके, सो यहाँ से क्या मिल रहा है जरा सा देखिए, 8e इंटू 4 माइनस एक्स स्क्वायर का होल स्क्वायर माइनस, हाँ माइनस क्या मिल रहा है हमें यहाँ पे, ओके सी दिस माइनस एंड दिस माइनस विल बिकम प्लस, डन. सो 2 to 4 4x स्क्वायर, एक बार चेक करना, टेक नो. So this minus will become plus 2 into 2 4x square, 4 minus x square, this one 4 minus x square का whole square. Now listen me very carefully. If the double derivative is greater than 0, at x equal to 0, then this implies VD is minimum. Or else, if double derivative is less than 0 at x equal to 0, means at this value, we need to check at this value, then VD is maximum. Please check at x equal to 0, this is positive or negative? It is always positive, because if you put x equal to 0, you will going to have the positive value. Hence, whatever VD value you are going to get at x equal to 0, it will be minimum, not maximum. In this way, we need to check. Then how to get the maximum value? As I told you, if the range is given, then on that range also we need to find the function value. Suppose VD at x equal to minus 1.5. Suppose at x equal to minus 1.5, it is coming, let me take minus 1.33 volt. I am assuming that you are getting this. And also we are having one more extreme point, which is plus 1.5 at x equal to plus 1.5. And here you are getting minus 7.43. I have taken only example. And while solving at this particular point, we have got VD as 0 volt at x equal to 0. Definitely those x value has to be lie in this range. अगर ये 0 नहीं होता ना, मतलब मान लो अगर ये -5 आता, x is -5 आता, तो हमें बाकी की चीजें देखने की जरूरत ही नहीं थी. क्यों? क्योंकि वो रेंज में ही नहीं आ रहा है, क्योंकि वो गिवन रेंज में ही नहीं है. So those things are valid if it is lying on the range. Now suppose we have calculated VD at x equal to 0, which is 0 volt. Now among these three, what is the maximum value? It will be 0 volt. Then in that case, this answer would have been correct. But are we getting the negative value at x equal to minus 1.5? Please check it here. In this, at x equal to minus 1.5 and also at x equal to plus 1.5, are we getting the negative value? No, we are getting, कहाँ गया? We are getting 9/7 sin 314t. So since this is greater than your 0 volt, since this is greater than your 0 volt, therefore the correct answer is 9/7. क्लियर हो गया टेक्नो? कोई डाउट? Okay, so take this question as homework question or practice question. This is the second last question. Okay, and please do solve. Please do solve and write your answer in the chat, in the comment box. Once this session is going to be over, please take the screenshot of it. If you want, you can take the screenshot of it, and please solve it. सर आंसर बी हाई बोला था सर, मैं समझा नहीं टेक्नो. ओके, एनीवे, so this is the practice question or a homework question you can say, and once this session is going to be ended, please do solve it and answer whatever option you are getting. Please comment it. I will going to see each and every student answer. All right, so let us come to the last question that we have in the today's session, which is this one. Okay, so let me give you 1 minute for this, not more than that. Your time starts now, not more than that, only 1 minute. Do it fast. Again, this is MSQ question, and we need to choose which of the following option are going to be the correct one. Times is going to up. Done. All right. So this is MSQ question. Which of the following equation can be derived from the AC bridges shown in the figure 1 and figure 2? Assume del L by L equal to 0.1 and R equal to omega L. So this is figure 1 and this is figure 2, and we need to find the output V01 and V02 value and the relation between those two. Okay. So this is the circuit 1 or the figure 1. Let me take the voltages here. Okay. So let me take the voltage here as plus minus V1, this is plus minus V2, or better to write here plus minus V1 and plus minus V2, because this is your supply, and from here current I1 will come and here current I2 will come. Okay. Now apply KVL in this loop. In this loop क्या मिलेगा? Minus V2 plus V1 plus V01 equal to 0. So V01 is equal to V2 minus V1. So where is V2? V2 is here. Now see, this I2 current is same in both the element, and what is voltage here? This is your voltage Vs. So in this branch the total voltage is Vs. So and since the current is same, I can directly apply the voltage division rule. So V2 is nothing but Vs same by sum R upon R plus R minus, now V1 is here, apply KVL in this loop because I1 is same in this current, sorry, in this branch. So it will be again Vs times j omega L plus minus del L whole divided by sum. So j omega L plus minus del L plus j omega, this value now, L minus plus del L, like this. Now you must be wondering, sir, which sign we need to take. So look at here. Suppose x is 2 plus minus 1 and y is 3 plus minus 8. Then z, which is equal to x into y. क्या होगा? ध्यान से सुनना. If you are taking the plus value here, na, which is in upper part, then in y also whatever sign we are having at the upper one, we will have to consider. मेरे कहने का मतलब, अगर आप प्लस ले रहे हो जो ऊपर साइड है, तो z का भी जो भी ऊपर साइड में साइन होगा वो कंसीडर करना है. अगर आप माइनस लोगे और माइनस कहाँ है? नीचे के साइड है, देन इन y also we will have to take the sign which is on the डाउन साइड और एट द बॉटम साइड. ठीक है, समझ में आ गया? सो हियर इट विल बी vs by 2 minus vs. Look at here, j omega will be cancelled out. So we are left with L plus minus del L whole divided by L plus minus del L here plus L minus plus del L. Now as I told you, if you are taking plus here, then here it will be minus. If you are taking minus here, then here downside you are having plus. So you will have to consider plus. So anyway, this will going to be cancelled out. This will going to be cancelled out. So what we are having, vs by 2 minus vs, okay, L plus minus del L whole divided by L plus L which is 2L. ये कॉन्सेप्ट समझ में आया क्या? हाउ आई हैव कैंसल्ड, टेक्नो, विनोद, एवरीवन, हाउ आई हैव कैंसल्ड. ओके, सो यहां पे क्या मिल रहा है? सी, vs by 2 minus vs by 2, like I have separated this term, it will be 1 by 2 here plus minus del L by 2L. So since it is vs and it is negative sign, na, so minus into plus, it will be minus, है कि नहीं? Minus into plus, minus, again minus and minus, it will be plus. Next, vs del L by 2L by 2L. So this is cancelled out. So let me write here. Let me write here. So it will be V01 will be, so minus plus Vs upon, see, del L by L, it is given in the question, del L by L is 0.1. So 0.1 by 2 is nothing but Vs by means 1 by 20, है कि नहीं? 0.1 by 2 is 1 by 20. So V01 is minus plus Vs by 20. V01 is minus plus Vs by 20. As of now, option B is correct. Now let us find V02. Again same thing. So let me take here plus minus V1, here plus minus V2, because here current is like this I1 and here current is like this I2. Apply KVL in this loop. So we are going to get minus V2 plus V1 plus V02 equal to 0. So V02 is V2 minus V1. Again same, apply KVL. So V2 is here, which is resistance R, and this I2 current is in series. So total voltage is Vs times R upon R plus j omega L plus minus del L minus V1 Vs. Okay, So what we have, this R whole divided by impedance, total element R plus j omega. This is L minus plus del L. All right. So in the question, it was mentioned R as omega L. R as omega L. So replace R with omega L. So Vs R as omega L. So omega L upon omega L plus j omega L plus minus del L minus Vs omega L upon. Guys, please do like the session and also please inform the others, those who have not joined, to watch the session once the video is going to be uploaded, or if they want to join live, you can share the link. Now here omega is going to be cancelled out like this. So क्या मिला हमारे पास यहाँ पे Vs, we will be having L upon, look at here, here we are having L plus j, L plus minus del L minus Vs, यहाँ पे क्या मिला, L upon L plus j, L minus plus del L. Okay, so here what I will going to do, I will divide the numerator and denominator by L, or take L as common. What we are going to get? Vs. Once you take the common, you will be getting 1 upon 1 plus j L plus minus del L by L. क्या ये समझ में आया? Everyone is getting this or not? Vs. Again, same here, take L as common. So 1 upon 1 plus j L minus plus del L by L. Okay, all right. So Vs 1 upon 1 plus j. Okay. So separate the numerator and denominator, like numerator in the sense, in the denominator this part is numerator and this part is denominator. So we can write this as 1 plus minus like this. Del L by del is 0.1 minus Vs times 1 upon 1 plus j 1 minus plus 0.1. Like this we can do. Okay, yeah, it seems to be a bit lengthy. Plus B stay here. You will going to learn some different thing. Okay, some different concept. Now taking the LCM by taking Vs common, let us see what we are having. So it will be 1 plus j 1 minus plus 0.1 minus this part minus 1 plus j 1 plus minus 0.1 whole divided by 1 plus j 1 plus plus minus 0.1, here 1 plus j 1 minus plus 0.1. Okay, all right. So is anything cancelling out over here? Okay, look at here everyone. Vs 1 plus j 1 minus plus 0.1 minus plus 0.1, next minus 1 look at here, this minus will come here, this minus will come here. Instead of taking minus here, I will multiply here, or else what we can do, ठीक है चलो, minus 1 minus j, why to complicate this, let us make it simple. Minus j 1 plus minus 0.1 plus minus 0.1. Okay. Now in the denominator part, please look at the denominator part very carefully. It is like if you are taking plus here, then it will be minus here. If you are taking minus here, it will be plus here. So ये क्या हो गया? A plus B और here यहाँ पे A minus B like this. क्या ये समझ में आया? और even not, then we can directly write this particular thing. ये जो है ना यहाँ पे, इसको directly लिख सकते हैं. Like if you simplify this, take plus here, minus here, or else minus here if you are taking, then plus you need to take here. In both the cases, the denominator part will be, let me write here, denominator part will be 0.01 plus 2j. 0.01 plus 2j. समझ में आया मैंने क्या बोला? टेक्नो एंड एवरीवन, इफ यू आर टेकिंग प्लस हियर देन माइनस यहाँ पे लोगे. अगर माइनस यहाँ ले रहे हो तो प्लस यहाँ लेना पड़ेगा. इन बोथ द केसेस डिनोमिनेटर विल बी सेम. ओके. Now in the numerator, let me write here itself, in the numerator itself, it will be minus j1, है कि नहीं? It will be minus j1 और यहाँ पे, sorry, minus plus j 0.1. Let me check, minus plus j 0.1. क्या ये समझ में आया? मैंने क्या चीज लिखा है? टेक्नो. कोई डाउट यहाँ पे? ऑलराइट, कुछ नहीं किया, बस मैंने यहाँ पे मैंने इसको मल्टीप्लाई कर लिया बाय टेकिंग दिस माइनस साइन हियर. सो सी इज एनीथिंग कैंसिलिंग आउट. लेट अस ओपन दिस थिंग एज वेल. So it will be plus minus or minus plus, I guess it was minus plus j. Okay, so what is cancelling out here? Plus 1 and minus 1 is cancelled out. Plus j1 and minus j1 is cancelled out. So we are left with vs minus plus j. So it is minus plus j 0.2. Done. Whole divided by. See, the real part is very, very less when compared with the imaginary part. So we can neglect this real part. So it is 2j. So j and j will be cancelled out. So we are left with minus plus vs by 10. So 0.2 by 2 is 0.1, which is 1 by 10. So minus plus vs by 10. Are this equal? We have obtained v naught 1 like this. So therefore both are not same, but v naught 2 is minus plus vs by 2, which is in option C. And since those two values are not equal, so option A is also correct, but not the option D. So the correct option for this question is option A, option B and option D. Any doubt? Difficult to digest, because there are lot of things, minus, plus and so on so forth, like when to take plus, when to take minus. It is difficult to digest, or it is difficult to understand as of now. But my dear friend, I am 100% sure that once this lecture is going to be uploaded, go through the video lecture again, and you will going to understand each and every flavor of the question. All right. So any doubt? Those who are present here, any doubt? And even once the video is going to be uploaded, or once the session is going to be over, basically, if you are having doubt at that particular time as well, you can ask me. Okay. But at the time of the exam, sir, can you elaborate your query, Techno? Maybe like at the time of, it's not possible to solve. Yeah. Such kind of question will never be asked in the GATE exam, like such lengthy problem. But the small portion of this, like see, small portion means only they will ask you, please give the value of V naught 1, give the value of V naught 2, but not the both. Like such kind of lengthy problem will not be given in the GATE exam. The GATE authority only want to check your basics. They don't want to be get you in the trouble by giving you such lengthy problem. ठीक है, वो खाली आपका बेसिक चेक करना चाहते हैं, तो वो इजी क्वेश्चन दे के भी बेसिक चेक हो सकता है. So please do not think in that manner, sir, how I can be able to solve such lengthy problem. You will never ever going to get, but a part of it you will going to get in the GATE exam. Is it clear, Techno? Any doubt? If you are having any doubt, please do let me know. I am here to rectify all the doubts. Okay. So meanwhile, let me take a few minutes. So this is our live online program, and it is for GATE 25 and for GATE 26, where we are giving the 800 plus hours of live classes with the live interaction. So whatever syllabus we are having, if you are from EE, if you are from IN, from EC, from mechanical, civil, computer science, so on and so forth, we are providing you like 800 plus hours of the live class in a live interaction, just like we are doing now. You will going to experience some different thing through our interface. So yeah, we are giving 800 plus hours of the live classes. Again, next thing, theory book plus exercise book plus 30 plus year of the GATE question bank with video solution. So we are providing the theory book for every subject, exercise book, as I told you at the starting of the class, that the exercise book are curated to help the student in such a manner that that they first develop the basics by solving the level 1 question, then go to the level 2, then attempt the level 3 question. So level 1, level 2, level 3 are the difficulty of the question. So this is how we have framed the exercise book. So, and again we are giving the GATE question bank with the video solution of 30 plus years. Next, 12 personalized one-to-one mentorship session means where the students are going to get the chance to interact personally, one-to-one, and whatever doubt they are having, they can ask. Next, 130 plus online test with video solution plus mock test and many more. So if you want to counsel yourself, you can call on to this number, or the link is already given in the description box. You can click on that, fill the form. Our counseling team will going to help you out. Techno, sir, आप full course YouTube पे नहीं पे ही करोगे ना? Full course in the sense ये GATE score booster है Techno. So in the GATE score booster session, I am covering all the syllabus of the measurement from EE and IN through the question. Like I am not going to take the theory portion, because you understand that it is not possible to take as it is YouTube. So but anyway, we are here to help the student community or the GATE aspirant. So whatever question I am having or whatever question I have framed, maximum concept I am trying to cover. Only I had taken the electrical machine also, the GATE score booster session. मैंने electrical machine का भी लिया है, तो आप हमारे YouTube चैनल पे जाके उसको भी देख सकते हो. माई सेल्फ निखिल गौरव, तो निखिल गौरव गेट स्कोर बूस्टर सेशन इलेक्ट्रिकल मशीन लिखोगे तो आपको दिख जाएगा टेक्नो. Okay, so yeah, this is the part 1. Okay, this is the part 1. So this is about our live online program, and the PDF of this session, the PDF of this session, which is a part 1, you will going to get in our Telegram group. So please do join our Telegram group, because you will going to get the schedule of the free YouTube lecture. Like even if you are going to miss the session or the timing of the session, you can directly find in our in our Telegram channel. Next, lecture PDF at free of cost. Like this session PDF is going to be posted in the Telegram group. Important update related to the seminar and webinar, PSUs and other government job notification, expert session on the important topic, and the daily quizzes and many more. So how you can join? By clicking on the link which is already given in the description box, or else you can visit to this Telegram ID. Alright. So with this we have completed the part 1, and we have covered almost 4 chapters, or you can say 50% of EE and IN syllabus. So the remaining syllabus we will going to cover on tomorrow. The timing is same from 6 p.m. onward to till 9 p.m. And on tomorrow session we will going to cover the CRO, cathode ray oscilloscope, Q meter, DVM, and one more chapter we are forgetting, Q meter. Okay, so the remaining 50% we will going to cover on tomorrow, which is part 2. So guys, again please do like the session if you have enjoyed, and please do share the session link with your friend, and please do subscribe our YouTube channel. It is very, very important. And if you want yourself to be the first one to be here in a live manner, then please press the bell icon, which is very important. Alright, so TechnoVD, thanks sir, आप अच्छा पढ़ा रहे हो. Thank you for such motivation and a kind work. Such kind of words always keeps me or the other faculty to be get motivated. तो आप इसी तरीके से सपोर्ट करते रहो हम लोगों को. डेफिनेटली इसी तरीके से हम लोग और फ्री यूट्यूब इनिशिएटिव आपके लिए हम लोग लाएंगे. सो डेफिनेटली आप कल आना टेक्नोवीडी, बिकॉज द पार्ट 2 वी आर पेंडिंग विथ. सो आप कल का लेक्चर भी एंजॉय करने वाले हो. सो बाय बाय एंड टेक अ वेरी गुड केयर ऑफ योर हेल्थ.